Hey guys, so today we are going to be learning about the midpoint and distance formula. So if you think about last section, we were talking about the segment addition postulate and how we could break up a segment into its smaller segments, basically add up all the lengths, and that was the length of your entire segment, right? And then towards the end of those notes, I used the example of if we had um, snapped the ruler at the 6-inch mark, and we called that 6-inch mark the midpoint. So all of that worked really well when we had horizontal or when we had vertical lines. But when we look on a coordinate plane and we have a graph and they have a slope to them, things are a little bit different. So that's where we use the midpoint and the distance formula. We're going to start with the midpoint formula here. So your midpoint formula, if you have one end of your segment, if that coordinate is at x1, y1, that's point A here, and point B, the other end point, is at x2, y2, then if I want to find that midpoint, right, that halfway mark, I'm basically taking the average of the x's and the average of the y's, right? So for the x of my midpoint and for the y of my midpoint, I'm just taking the average of my x's and I'm taking the average of my y's. That's how we would find the midpoint of any segment there. So when I look at example 1, and it says the endpoints of segment RS are at 1, -3, and 4, 2, and we want to find the coordinates of the midpoint, we're going to take the points from R as x1 and y1, and the points from S as x2 and y2. So when I go to find the x coordinate and the y coordinate of my midpoint, I'm going to take 1 plus 4 and divide it by 2. And then I'm going to take -3 plus 2 and divide it by 2. This is going to give us our midpoint. So 1 plus 4 is 5. We can write it as just 5 over 2 or 2.5. It doesn't matter. And then -3 plus 2 gives me -1/2. So this M, that point M, would fall at 5 halves and -1/2, and that would be the midpoint of that segment. Okay. You guys can try to pause the video, and you guys can try number 2 on your own, and then we'll go over it together. Okay, to find the midpoint of AB when A is at 1, -3, and B is at -1/5. Our midpoint, again, we're going to take the average of the x's, so 1 plus -1 over 2, and we're going to take the average of the y's, so -3 plus 5 over 2. When we go to find that midpoint now, -1 plus 1, or 1 plus -1 is 0. 0 divided by 2 is still 0. And then -3 plus 5 is 2. 2 divided by 2 is 1. So we should find on number 2 that our midpoint is at 0, 1. On number 3, when it says to find the midpoint of CD, it says the midpoint of CD is at 2, 1. We know one of the endpoints, C, is at 1, 4. We have to find the other endpoint. Okay, we had said the x value of our midpoint and the y value of our midpoint was just taking the average of our x's and the average of our y's. So if I have my midpoint and I need to find the x of my other endpoint, or if I need to find the y of my other endpoint, I'm going to use my midpoint formula. I'm just going to plug in what I know. So I know that the x value of my midpoint is 2. So I'm going to have 2 equals the x value of one of my endpoints, which is 1, plus the x value of my other endpoint, which I don't know, and then divide it by 2. To solve this, we'd have to multiply both sides by 2. Okay, that's just going to cancel out this fraction. That's going to give us 4 equals 1 plus x. Subtract the 1, we'll get x equals 3. Okay, so if you think about the other endpoint D being a coordinate pair, We have our x value. We still have to find the y. So same idea. Our midpoint, our y value, is going to equal the average of our y's. And I'm going to just plug in what I know. I know that the midpoint, the y value on my midpoint is 1. I know that the y value on my one endpoint is 4. I have to find the y value of my other endpoint. So I'm going to multiply both sides by 2. Again, that cancels my fraction. I'm left with 2 equals 4 plus y. Subtract the 4. We get y equals -2. So the other endpoint would be at 3, -2. When we look at number 4, okay, it's the same process. We'll do one more as practice. On number 4, it's the same process. I have my midpoint and I have one endpoint, but I have to find the other endpoint. So we know that the x value of my midpoint is equal to the x value of one of my endpoints plus the x value of my other endpoint divided by 2. When you multiply, we multiply both sides. That doesn't change the fraction. It just multiplies over here. So we would get 10 equals 1 plus x. Subtract the 1. We'll get that x is equal to 9. So on endpoint B, my x value is 9. For my y value, I'm going to have the y of my midpoint equals 2 plus y over 2, right? So the y value on one endpoint plus the y value of the other endpoint, which I don't have. We're still going to go through the same process, multiply by 2. We get 8 equals 2 plus y. Subtract your 2, we should end up with y equals 6. So our other endpoint should be at 9, 6. So really the difference between 1 and 2 and then 3 and 4 is 1 and 2. I was giving you the coordinates for your endpoints, and you didn't have the value of your midpoint. For 3 and 4, I'm giving you the value of one endpoint, I'm giving you the value of the midpoint, and you're using that information to find the other endpoint. Okay, so you're still using the same formula, you're just plugging in your values into different spots. So go ahead, you guys can pause the video, try number 5 on your own, and then we can talk about it together. Okay, on number 5, our midpoint is at -1, -2. One endpoint is at 1, 4. We want to find the other endpoint v. So the x value of my midpoint is equal to the x value on one endpoint, which is 1, plus x over 2, right? The average of my x's. So multiply by 2, we get -2 equals 1 plus x. We can subtract 1, we get x equals -3. So that's half of our coordinate. We still have to find the y value. The y value of my midpoint is at -2. That's equal to the y value of one endpoint plus y, right? The y value of the other endpoint, which is what we're looking for. We can multiply both sides by 2 to solve. We get -4 equals 4 plus y. We can subtract 4, and we should end up getting y equals -8. So that other endpoint will end up being at -3, -8. So that's the midpoint formula. Out of the two formulas today, that's probably the easiest one. When you're just trying to find the midpoint, it's pretty simple, right? Just taking the average. If you have to find one of the endpoints, a little bit more in depth, but it's still pretty manageable. Okay, that brings us over to the distance formula. In this diagram in your notes, we have a right triangle here. The distance formula is derived from the Pythagorean theorem, which you guys probably had learned sometime in middle school, which we will get to this year. It's just not anytime soon. So I will go back over how the distance formula is derived from the Pythagorean theorem, but for right now, looking at the distance formula, if I wanted to find the length of AB, again, if we think about the last section, we were able to find the lengths pretty easily if I had a horizontal or a vertical line, but this time it's sort of on a slope here. So if I have the coordinates, again, A, one of my endpoints is at x1, y1, and my other endpoint, B, is at x2, y2. To find the distance between them, or to find the length of this segment, we're going to use our distance formula. If you need to rewrite it so it's a little bit clearer, I know it can get smushed on your copy. You're taking the distance of AB as the square root of, we're going to start with the difference of our x's. So we're going to do x2 minus x1 and square it. And then we're going to add the difference of our y's, the x2 minus x1, and then square that as well. That'll give us the length or the distance between points. On some of these, we're going to go through and just kind of plug it into our calculator, see what we get. Sometimes our directions will ask us for a decimal. Sometimes it'll ask for a radical. So we'll go over the radicals in this aspect here. So on letter A, if I wanted to find AB, the length of AB, I'm going to take the distance of AB as the square root. I'm going to take the difference of my x's. I'm going to start with negative 3 minus 0 squared. I'm going to add in the difference of my y's, so 8 minus 2 squared. And then we're going to keep solving, okay? So negative 3 minus 0 is negative 3. We're still going to square that. 8 minus 2 is 6. So I have negative 3 squared plus 6 squared. Negative 3 squared, when you multiply that out, is 9. 6 squared is 36. And then when we add those together, we get the square root of 45. Okay, so we're going to keep these in radicals for right now. I'll show you in a couple of pages when we're going to change it to decimals. But if we're going to keep it as a radical, we want to make sure that our radical is in its simplest form. So we're going to break down the 45. I'm going to break it into 9 and 5. I'll break my 9 into 3s. We're going to take our pair of 3s out. That's going to reduce down to 3 square roots of 5. So the 3's come out and the 5 stays in the radical. Same idea on letter B. We're going to take the square root, and I'm going to start with my x's. I'm going to do 1 minus negative 3 squared. And then I'm going to do my y's, negative 7 minus 5 squared. That double negative turns into addition, so 1 plus 3 is 4 squared. Negative 7 minus 5 is negative 12 squared. Oops. Okay, 4 squared is going to give me 16. 12 squared is 144. So 16 plus 144 is 160. Again, we want to break it down. I'm going to break this into 16 and 10. 16 breaks into 4 and 4. 10 breaks into 5 and 2. We had seen before the 4's are a pair, so we could take those out. Even if you didn't, you could keep breaking it into 2's. You would take 2 pairs of 2's out, which would still become 4. Can't break out the 5 and the 2, so our final answer on letter B would be 4 square roots of 10. And the 10 is coming from the 5 times 2 that was left inside the radical. Okay, so again, pause the video, take a second, try to do C and D. You guys can forget E and F. I think at an honors level, you guys don't need 4 more different practice problems. So just C and D will be fine, and then we'll move on to the next page. Okay, on C, if I'm trying to find the distance of EF, or the length of EF, I'm going to take my square root. I'm starting with my x's. So 2 minus negative 1 squared plus 6 minus 5 squared. Okay, you'll see on this one I started with the 2 and the 6 instead of the negative 1 and the 5, which before I was starting with the second point. It really doesn't matter which point you start with, just stay consistent. If I start with the 2, make sure, if I start with the 2 and the x's, make sure you start with the 6 and the y's. Same thing as above. I was starting with the second x and then doing x1, start with the second y. Just stay consistent. Okay, so the double negative becomes addition. We end up with 3 squared. 6 minus 5 is 1. We have 1 squared. We know 3 squared is 9. 9 plus 1 is 10. And we really can't break down the square root of 10 at all. So that would end up being our final answer on C. On D, if I wanted to find GH, same thing. It doesn't matter which one you start with. I'll go back to the second minus the first. I'll do 6 minus 4 squared. And then negative 8 minus negative 6 squared. Double negative again. So 6 minus 4 squared would give me 2 squared. And then negative 8 plus 6 would give me negative 2 squared. Okay, so I have 4 plus 4 again. That'll give me the square root of 8, which again we want to try to simplify, keep it in its simplest forms. So I'm going to break it into 4 and 2, and then break down the 4 into 2's. We can pull out a pair of 2's, and our final answer here should be 2 square roots of 2. Okay, so that is our distance formula. Again, you don't necessarily have to worry about E and F unless you want some more practice. Number 1 also kind of just goes back to our last section of notes when we talked about the midpoint on a straight line. So I know you can't really see these letters on your handout, but this is Q, S, R, T, and then your midpoint is the middle here. So if I know the length of QM is 18.5 and we wanted to find QR and MR, right? So if QM is 18.5 and it's the midpoint, which is what it tells us already, because we would use the word bisect. Remember, bisect means it cuts it in half. So if I know that ST is bisecting QR, then M is my midpoint, and if QM is equal to 18.5, then MR also has to equal 18.5, right? And that means that QR has to be double that, right? You could add them together, you could double them. Either way, we should find that QR has a length of 37. Okay. Then we get to number 2 here, example 2. It says the diagram shows the positions of 3 players during part of a water polo match. Player A throws the ball to player B, who then throws it to player C. So we're going from here to here to here, and now we're going to round our answers to the nearest tenth. So it says in letter A, how far did player A throw the ball? So I need to find the distance or the length of AB because that's where player A threw it. I'm going to take the square root. I'm going to do 18 minus 8 squared plus 7 minus 4 squared. And if you want to, you could really plug in this whole equation into your calculator. So let me see if I can make this smaller. Okay. So right now, if I wanted to plug in the square root of 18 minus 8, I'm going to take my square root symbol. You guys can do this on your graphing calculator. I'm going to put in the parentheses and do 18 minus 8. And then I'm going to raise that up to the second power. And then I'm going to add. Then I'm going to add. And then I'm going to do 7 minus 4. And then raise that up to the second power. So this will give me a decimal right away when I click enter. And if I scroll over here, let's see, hit the send button. Do this to evaluate it. So here's my decimal form, is this 10.4. Okay, I don't actually love this online calculator, but for right now, showing you guys it's the best we can do. So that's AB, right? We wanted to round to the nearest tenth of a meter. So you guys can pause this. You guys can try figuring out how far B through to C, and if A through to C, how far that would be as well. So go ahead, pause it, and try letters B and C here. Okay, on B, to find the distance from B to C, we're going to take the square root of 24 minus 18 squared plus 14 minus 7 squared. And again, I'm going to go over to my calculator here. I'll scroll down, and then I'm going to type in, I'm going to have my radical, and then 24 minus 18 squared plus 14 minus 7 squared. My answer here in my decimal form would be 9.2, rounded to the nearest tenth. So 9.2 meters, and then the last one, how far would player A have to throw the ball if they threw it directly to player C? So that would mean I'm going to find the distance from A to C, so I'm going to take the square root, and I'm going to do 24 minus 8 squared plus 14 minus 4 squared. Okay, that's what I'm going to plug into my calculator. Again, when you need it as a decimal, if you plug all of this in, it's nice and easy. It shoots it right back out at you. So when I retype this one, I'm going to go down here, radical, and then parentheses, 24 minus 8 squared plus 14 minus 4 squared. And then if we hit enter here, we get the answer as 18.9 meters when we round that. Okay, so again, using our distance formula, but you are able, and we can go over it in class, I'll show you on the graphing calculator as well, we can go over how we actually can just plug these into our calculators to get the answers right away. You still need to know your formula, but it's just an easier step than when I was going step by step above. On the back of your packet, on example 3, it says, as shown, a path goes around a triangular park here, and it says find the distance around the park to the nearest yard. So if I wanted to find the distance around this park, I need the length of PQ, the length of QR, and the length of PR, which I can find PQ pretty easily, and I can find QR pretty easily because we have a vertical and a horizontal line. So for PQ, if you just notice your scales here, we're going 10, 20, 30, 40 yards. If we're looking at QR, we're going 10, 20, 30, 40, 50, 60, 70 yards. So we don't need to use our distance formula on all three sides here. We will need it for PR, but we could count pretty easily for PQ and QR. So for PR, if I wanted to find my distance formula, first off, P is at the point 1050, and R is at the point 8010. So I need those values for my distance formula. So I'm going to take the square root. I'm going to do 80 minus 10 squared. And then I'm going to do 10 minus 50 squared. And again, because we're looking at an actual real world situation here, I'm going to put it into a decimal. So I'm going to go back to my online calculator. I'm going to do the square root of 80 minus 10 squared plus then 10 minus 50 squared. And that will give us about 80.6 here. So PR has a length of about 80.6. And then we need to go through and we need to add all three of these sides to find the distance around the park. So for letter A, we're taking 40 plus 70, which is 110. 110 plus 80.6 would tell me that the distance is about 190.6 yards all the way around this triangular park here. Okay, and then on B it says a new path and a bridge are constructed from point Q to the midpoint of PR. Find QM, right? So M is going to be my midpoint once I find it, to the nearest yard. So the first thing is, if I don't have my midpoint, which I don't, I need to find it. So again, I have my values for PR here, my coordinates. We need to go back to our midpoint formula, which said we're going to take the midpoint as the average of the x's, so 80 plus 10 over 2, and the average of our y's. This is going to give us the midpoint so that we can use that distance formula to find the length of that bridge. So 80 plus 10 is 90. 90 divided by 2 is 45. And 10 plus 50 is 60. 60 divided by 2 is 30. So at 45, 30, we have point M, and it's saying a new path and a bridge are constructed from point Q to point M. So we want to find this length now. So for Q is at 10, 10. We're going to find the distance of QM. We're taking the square root, and we have, we can do 45 minus 10 squared plus 30 minus 10 squared, and get that distance here. So I'm going to take the square root, 45 minus 10 squared plus 30 minus 10 squared. It's going to tell us that QM has a length of 40.31 or 40.3. Okay, so again, that is your midpoint and your distance formula. You do have a bookwork assignment that goes along with this, so just go back on Google Classroom. You guys will see the bookwork. I believe it was page 19 through 20, numbers 3 through 45 odd. Okay, I think that's what it is. If you want extra credit, just do all of them. Okay, I know I wasn't there today. I will be here tomorrow. Okay, I know it's a little bit hard trying to learn off of a video, but as long as you kind of followed through, this is basically exactly what I would do normally in class with you guys. I don't always love doing this, obviously. I hate doing math on a computer, but we'll get through it today, and I will check this homework next class when I see you, and we will certainly go back over anything that you guys need to talk about in more detail when I see you again tomorrow.